Okay, so once again, hi guys, hi everybody. My name is Jacek, and as a member of the Meet and Code team, I'd just like to briefly introduce you to the initiative and just say a few quick words about the project. But first, a very, very warm welcome from our partners, which are Stiftens, TechSoup Europe, SAP, and the German Federal Ministry of the Interior. And now we can begin, and welcome to our third online seminar of 2021. And if you're new, let me tell you just a bit about Meet and Code. And Meet and Code was launched in 2017 to assist nonprofit organizations in providing digital skills education to young people aged between 8 and 24 years old across Europe. And now, five years on, Meet and Code has reached more than 175,000 young people across 35 European countries. So that's a lot. Giving them the digital literacy and coding skills to, let's say, thrive in tomorrow's competitive digital economy. And Meet and Code, what do we do? Meet and Code awards microgrants of as much as 500 euros to local nonprofits to facilitate the workshops and the classes they deliver. And many in our audience today will undoubtedly be recipients of those grants. And to answer your question, why have we launched the Meet and Code online seminars? So this series is an extension of the Meet and Code commitment to just help nonprofits become more innovative and creative in the work they do. And they are designed to simply inspire all of you, our Meet and Code community, with some learnings and insights from great SAP speakers and coaches in the exciting world of IT and coding. And one of these coaches is with us here today. So we are delighted to have Jadga Huegle with us today. And Jadga was originally a biologist and discovered her interest in computer science while building a small connected greenhouse. And since then, she has become a SNAP and CS education devotee, and she's eager to share her excitement with everyone. Jadga works for SAP SNAP team and develops learning resources for schools and workshop facilitators. But as I'm sure, since it would be so much more interesting to hear about her story and the whole adventure, not from me, but from Jadga herself, I just want to say that we are super honored and grateful and hugely amazed that despite all your commitments, Jadga, you found the time to be with us today. So let's just dive right into today's topic and learn more about coding and how to teach coding virtually with Snap. And Jadga, over to you.
Thanks, Jacek, and great that you're all here. So I want to mainly talk about the how to teach programming part. We can cover the virtually part a little later, but I'd focus on the how to teach programming part. And as Jacek already mentioned, I'm working on the Snap team at SAP. So Snap is let me share my screen real quick. Snap is a visual block-based programming language that we develop at SAP together with colleagues and friends at UC Berkeley in California. And Snap was made for their introductory computer science class, which is called The Beauty and Joy of Computing. Wait, I can maybe post a link real quick. So that's the link to Snap. And here we have bjc.edc.edu, where you can find the curriculum that Snap was originally made for. And I want to show you now more about Snap and about how to teach your own classes in programming with Snap or with any other block-based educational programming language. So let's start from scratch, with Snap. Snap runs in the web browser at that URL that I just sent you. So those of you who already know Scratch might be familiar with the general website. So we have the latest projects here that people created. We have different, we call those carousels that have different topics. So those are just the latest projects. Here we have projects that we from the community liked. And then we have different topics, for example, music and art and stuff, where we can see what other people have made. And you can run Snap directly in your web browser. It doesn't run on the Internet Explorer, but any other web browser or modern web browser should work. And you can click on Run Snap to open the development environment. And what I wanted to mention first is you can change languages of the block texts and of the UI texts by going on that wheel thingy here. And then you can select language, and Snap is available in all those languages. So yours might be there, or I hope it's there. If not, feel free to provide a translation of Snap. So we're working, it's an open source project, and we're working with people from the community. If you're missing some blocks in your language, feel free to shoot us an email and we'll include the translations if you have them. But for today, I would just keep it in English because I guess that's the language that we all speak. So in the beginning, also, if you have questions, feel free to write them in the chat. I'll try to keep an eye on it. And if not, Jacek and Philip probably will and can just ask me the questions. So feel free to ask any questions you have in the chat. About Snap. So the first three things that I definitely want to mention is Snap is a visual programming language, which means you program by dragging and dropping together these bits of code, which we call blocks. Visual because you don't have to type, but you drag stuff together and it's these blocks. The blocks are in different categories. This one, the blue one, is motion, for example. It has to do with everything that moves your sprite around on the stage. Then we have looks, we have sounds, and so on and so forth. We'll go through the different categories maybe later. The next thing I wanted to mention is that Snap is a live programming language, which means that you can basically click on anything and it will run right away. So for example, if maybe let's input something bigger here. If I click on that move 20 block here and you take a look on that sprite on the other side, you can see that it now moves whenever I click that block. And I can also try that with the turn block or with the go to center block. So everything gives immediate feedback, which makes it easier to try things out. So you don't have to compile everything and then it doesn't work because you made an error. You can just explore everything and see what it does right away. And as I mentioned, you program by dragging and dropping blocks together. As a metaphor, we call this part of the window the stage. And you can think of yourself as a director of a play, and you're directing something that happens here on the stage. Those so-called sprites are the actors and actresses in your play, and what they have to do is what you program here. So for example, I want to make a play where my actor or actress moves 20 steps and then turns 15 degrees, and it does that all the time. Oh, let's wrap a forever around it. And I click that, and now my actor does that on the stage. So again, Snap is a visual programming language and it's live. I can click everything here and it runs and it stops. I could, for example, also set it back to the center and it does that while it's running the script. Besides being live and visual, Snap is also a parallel programming language, which means several sprites, several of those actors, actresses can run at the same time, and several scripts in one sprite can run at the same time. Let me show you what that means. I'll delete that. And we add a when space key pressed block. So those are called head blocks, and I can put them on top of a script to trigger the script that's below them whenever that event that's written on here happens. So in this case, I can trigger the script when I press the space key. And what we want to do is when the space key is pressed, we want to forever move one step. Okay, let's try that. Works great. Okay. Then I can make another script that also starts when the space key is pressed. So here, for example, I build another when the space key is pressed forever turn 1 degree step script. And now I can start both of them when pressing the space key, and they both run at the same time. So now I'm moving one step, but I'm also turning one step at the same time. That's why my sprite moves in a circular structure. Floor just asked in the chat, what's the difference between Snap and Scratch? And I will come to that in a minute, because you're totally right. It looks the same. Maybe I'll also spend 1 minute to elaborate on the history of Snap a little bit, because that's closely related to the history of Scratch. So parallel programming language, parallelism in the same sprite. But I can also have multiple sprites that run at the same time. So here, for example, I can make another one that also starts on the space key and that also does forever things. And what it does is it moves 10 steps and then bounces from the edge. So now I can also run that at the same time. So I have this sprite running 2 scripts at the same time, and I can have this sprite running at the same time while the other sprite is running. So those are the 3 fundamental things, but as Flo already mentioned, those are also true for other educational programming languages. For example, Scratch is also a live programming language, a parallel programming language, and a visual programming language. The next thing I wanted to talk about is what makes Snap special. So the idea when we made Snap, I mean, I wasn't there at the beginning, so when Jens started to make Snap, was actually to have a programming language that has all those introductory features, but still allows powerful computations. So they want to use it in a course at university level. So this is an introductory university course the Snap is used for. So we need to cover specific things that, for example, Scratch doesn't have, and that are not necessary for really basic intro programming, but that we feel are absolutely necessary to do actual programming or computer science. And those, so there are several things, but I want to focus on 3 things that I want to mention. What Snap has compared to Scratch, for example, is local variables. So we have those script variables that we, for example, can use inside of custom block definitions. And if we run the block multiple times in several sprites or several in several scripts in one sprite, each of those variables can have a separate value. So we have real local variable scope. I don't want to show that, I just want to mention it. The second thing that I wanted to mention is that we can make custom blocks, but not only commands, but also functions and predicates. So one of the big things in programming is coming up with your own functions, functionalities that your programming language should have. And usually you write blocks for that. So for example, one block that I might want to do is a sum block. So I have a list of numbers, 1, 3, 5, 6. What is the sum of that? 11, 4, 15. So I want to calculate the sum of that. And I could now make a block that says item 1 plus item 2 plus item 3 and do that until the list is over. But I could also make a block for it. So here, if I click on the plus sign or make a block at the end of each category, I get to a block editor. And here I can select whether I want to make a command block, which I don't right now, or a reporter block, which I do want to do, or a predicate, which is a block that reports values, but only true or false. So those of you who already know Scratch or other block-based programming languages, you can distinguish different forms of blocks or shapes of blocks. So for example, we have those puzzle piece-ish looking blocks that we just used for the for this program here, which are so-called commands. So they tell the sprite what to do. And then we have those overly shaped roundish blocks, which we call reporters or functions. Those are blocks that report values. So in this case, for example, it reports the X position of my purple sprite, which is 91. And we have those hexagonal blocks that I just talked about, the predicates, and those are also reporters, but they can't report any value, but only true or false. So in this case, for example, 3 equals 3 reports true, 3 equals 4 reports false. So this are the only 2 outputs my block can have. And here I can decide which shape my new block is going to have. And in this case, I want to have a reporter, which I call sum, because it's going to calculate the sum. And then I already have my block here. which is pretty cool if you want to do more advanced things like recursion, because you can use the block definition inside the block itself, but that's another story for another workshop. And I now need an input where I can put the list in that I want to calculate the sum of. So I add an input here, and this is called, I don't know, numbers. And when I click apply now, you can always see how the block changes. And what my sum is going to report now is the combination of all numbers that I have using the plus block. So let's click apply here. And now I can input that list in here. And what I should get as a result is 15 if I calculated that correctly, and it works. So the cool thing is with that report block in here, I can create custom reporters. And we personally feel that this is something that's really important in programming. So if you want to calculate averages and stuff, and if you want to do statistical things or physics or whatever, you always need functions. And it's really important for us that you are able to build your own functions. Also, Snap has other features like even building your own control structures, but that's also another story. And the last thing I wanted to mention from those 3 points is multidimensional lists. So in Scratch, for example, you have lists, but those are basically, how to say that, a collection of numbers or words, and you can't use anything else as an input to that list block. And you can't make multidimensional lists. So what we feel is really important is working with data. So we need to be able to create different data structures. And one that we use a lot is tables. So lists of lists. And I can make that by just, for example, I have that list here. And that's one. Oh no, let's make just one with 2. We have a list, and this has a list as its first element with the numbers 1 and 1, and it has a list as its second element with the numbers 2 and 4. And if I click on that block now, what I get is a table, because that's just a list of lists. So if you want to see it as a list, I can also show it as a list view. So you see that each of those elements is another list with 2 elements. And that's also something that we feel really important, especially for things like media computation that we've been experimenting a lot with lately. So if I get another workshop with the Media and Code seminars, this will be my topic. I want to talk about media. And one thing that, for example, is represented as tables is images. So I can just take an image here. So this is me. And I can now take a look at the pixels from that image by using the pixels block from the costume category. This one has pixels as an input. And now I can look at the pixels of my current costume. This has 172,800 pixels, which is just like the height of the stage times the width of the stage. And each of those pixels is a list with 3 color channels, R, G, B, and an alpha channel. So if you want to do stuff with media or with images, for example, you need tables. If you want to do stuff with data, you need tables. So we've also experimented with general introductions to data science recently, and that's all on end, for example, artificial intelligence. And for all those models, for analyzing the data and things, you need tables. And that's why multidimensional lists is the third thing that I wanted to mention. If there are any more questions regarding the differences, feel free to ask them. I know some more, but those are the most interesting ones. Okay, so then let's come to the workshop part. So that was it about Snap. And now I wanted to give you some ideas on what I found useful doing workshops. The first one that I wanted to mention is, wait, let me start this, is start with simple projects. So a lot of kids, when they come to workshops, they have huge expectations. They usually have games in mind that they want to do that are overly complicated. So I usually recommend starting with simple projects, but by simple, I mean simple code but still a big result. So there are a few projects that I like a lot that are super easy to code, but still look visually appealing and beautiful. One I wanted to show you is the random color walk that I like as an intro. And I would suggest that I show you most of the projects just like that, and I program it and you watch. But I would like to do one together, if that's all right with you. Then we can do it step by step, so you've also done something today and not just listened to me. So this first project, as I mentioned, is called Random Color Walk, because we want to have differently colored lines on the stage, and we want the sprite to move around on the stage randomly. Whenever it hits the edge, it's supposed to bounce. That's it. So first of all, we need a move block, and then we need the if on edge bounce block. And we want to do that not only once, but forever. So I'll wrap forever loop around it and just try that. If you leave out the if on edge bounce, of course, your sprite leaves the stage. But as I mentioned, as Snap is live, you can just click on the go to X0 or Y0 block and then it comes back. If you input that block here again, you can even do that while the program is running, then the block will bounce again. So this is not particularly interesting. Maybe let's add some more interesting things to it. So for example, it would be cool if our sprite wouldn't only move from left to right, but would also have some angle. So for that, we could just add the turn block in here, maybe with 1 degree. So what I get here now is circular shapes, but whenever it reaches the edge, it just bounces. To maybe see what we're drawing, it's always a good idea to put the pen down with the blocks from the pen category. Then you can just see what you're drawing. So this is still not particularly beautiful. Maybe we can add some color to it. So for example, we could set the pen color to something bright at the beginning. Let's do red, and then we can change the pen hue by, I don't know, 0.2 each time we turn, so we slowly get new colors. Now, for example, we got stuck here. So to make it a little more interesting, we could add some randomness. And that's also one good thing about the simple projects. Try to have one idea in the project that you can reuse for other projects. In this case, for example, it could be randomness. So if we have absolute values here, we might get stuck at some position, or we get the same image over and over again. So to add some randomness, we have a block in the operators category, which is called pick random. And for example, this block reports a value because it's overly shaped, and the value it reports is a number between those two borders. So in this case, 7 or 10 or 5 or whatever. So to have it sometimes move left, sometimes move right, I would just input small values between, let's say, -2 and 2. And if I use that as an input to the turn block, -2 and 2, my sprite will sometimes move left, sometimes move right, sometimes stay in the same direction. So let's clear that again and let's see how it looks. Okay, that's, maybe let's move a little smaller steps. That looks a little more interesting. Maybe we can increase the angle here even. Yeah, not that bad. Okay. Now that we have that, we could add even more randomness. So for example, we could change the pen color by a random value each time, or we could change the pen size by a random value each time. So for example, we could add a change pen size block and add the pick random block here as well. And randomness is really a good introductory concept because it makes everything more interesting, but it's super simple to grasp. So for example, we could, no, let's not change the pen size. Let's set the pen size to a random value, maybe between, yeah, let's do 1 and 10. And if I input that here as well, you see that my lines now get sometimes bigger, sometimes smaller, depending on which value I select randomly here. So again, pick simple projects that look beautiful. So if I run that a few times, I get a interesting looking result, and also try to get concepts across that are reusable in later projects. In this case, for example, it would be randomness. Another project, which is my absolutely favorite starter project. So I'll just create I'll just build it in here. Which is my absolutely favorite starter project is the flower field, because that's also super easy to do, but conveys a really good concept, the one of the total turtle trip. So for that, I'll draw a petal for my flower. It looks like this. One thing about Snap, the pen editor is not the best. We're working on it, but it still might need some time. So this is my petal. I need to move the rotation center somewhere to the top or bottom. Let's move it here. And now my sprite can wear that costume again. And if I want to draw a flower now, I can just stamp that object as it looks. But I need to turn in between. So let's clear that again. Also, let's make it a little smaller. I need to turn and then I need to stamp, or the other way around. That doesn't really matter. So now I need to click 24 times until I get a full flower. If I change the angle here, I need to click less. If I increase the angle, I need to click more often. If I decrease the angle, oh yeah, I forgot one. And the algorithm behind that is the so-called total turtle trip. So the number of repeats that you need is, or the angle that you need to turn is the number of petals that you want, and 360 divided by that number. So for example, if I want to have an 8-petaled flower, I repeat things 8 times, and the thing that I want to repeat is stamping and then turning, and the angle that I need to turn is 360, so the full circle divided by the number of petals that I want to have, in this case 8. So if I clear that now and I execute that, I get an flower with 8 petals. And the cool thing about that is it's an algorithm, and I found a generalized formula now that I can use in a new block, for example, but you can also use the exact same formula to, I don't know, create polygons and whatever. So that's also an algorithm that can be reused later on, and the script is super easy. So that's everything I needed. But the outcome is pretty great. So if I add like 2 more blocks, for example, forever, and go to random position, I can make my, and pen up, of course. I can make my whole screen full of flowers with just those 5-6 blocks. And it's a pretty impressive project, but the programming part is super small. So again, introductory projects should convey a message that you can use later on, and they should have a big result with simple code. Okay, the next thing I wanted to mention is accommodate everyone. So I know that a lot of kids love programming games. I personally am not much of a gaming fan, or not a programming gaming fan. And I know that there are some kids in workshops that feel like I do about games. So it's always cool to have some projects up your sleeve that don't have to do with programming. And what I found works particularly well is stuff with images. So with photos of yourself that you can make look funny, or that you can try to make more beautiful or whatever. So one project that I wanted to show is with the graphic effects from the looks category. So first I want to take a photo again, and I want to wear that photo as a costume. And what we want to do now with that photo is we want to apply graphic effects. The graphic effects blocks are both in the looks category. So there's a change effect by and a set effect to, and I'm going to grab the set effect to block. And there are different graphic effects, one that changes the color, the saturation, the brightness. Ghost effect makes the image more transparent. And now I want to try the fisheye effect. So the fisheye effect applies a fisheye camera on the center of that image. So for example, if I set the fisheye effect to 100, the center part of my photo gets extended. If I set it to a negative value, the center part shrinks. Oh, 100 is a lot. Maybe let's try -50. So that everything in the center is really small and everything on the outside appears big compared to it. It's already fun to just try around with that, but it's really easy to make an interactive project out of it by just like controlling the amount of fisheye effect that I have with my mouse pointer. So we have in the sensing category blocks with which we can interact with our environment. So for example, the mouse X and Y blocks, you can see the values here, change their reported value based on where my mouse is. So in this case, for example, I'm at mouse X position 103. So for example, if I wanted to set the fisheye effect to my mouse X position, I could do it like that. And if I click it once now, it's -749, so I can't really see anything. But we can do that all the time by just wrapping the forever loop around it. And again, with those 3 blocks, I made an interactive project where I can make my face look funny. And we could also, for example, add another effect, second effect, to the mouse, which is controlled by the mouse Y position. So for example, I could, let's do the whirl effect. I could set the whirl effect based on the Y position of my mouse. So if I'm in the center here, I can now whirl my face, and I can whirl my face and fisheye it at the same time, or I can whirl it in the other direction and fisheye it in the other direction. So again, this is a super simple project, but it's fun to do. And it has nothing to do with games. So this is a project that I really like as introductory things. Also, if you don't have webcams in your workshop, you can just download images from the internet and you can import them via the file menu and selecting import. So for quite a while, images from Donald Trump have been a huge hit in all workshops with that exercise. So people usually, or kids usually like to do it with their favorite animals, their brothers, their friends, themselves. So this is an exercise that I can highly recommend and that worked pretty well for me. Okay, the next point that I wanted to mention is look for expandable projects. And this is maybe the one that I wanted to do together with you. You would all need to create an image. So if you go to the, I'll just delete that one. If you go to Snap, so snap.berkeley.edu, and then click Run Snap, and then go to the Costumes tab, you can just create an image from yourself with the webcam feature. If you use the webcam the first time, you need to allow it in your browser. So here I have the webcam allowed on Snap thingy active, so you would also need to do that. If that doesn't work, just grab any image from your computer. So I have different ones. You can just drag them into Snap, and that works as well. So feel free to do either of these. And then we need to create a second sprite. So what we want to do now in this project, which we call pointillism, is we want to recreate this image that we have by just using colored dots. So we have another sprite that will, and you can create another sprite by clicking here, that will move across the stage randomly, will measure the color at that point, and then we'll draw a dot in a specific size in that color at that position. And we will later be able to see that because we make this first image transparent. But now we leave it as it is so we can see that we actually get the right color. So usually we introduce that project a little different, but we don't have that much time. So usually we just draw colored confetti first, and then we measure the color in the underlying image. But let's do it right now, right away with the image. So if you go to the pen category, you can find a block which is called Set Pen Hue To. If you click on that drop-down menu, you can see the other color components. So Snap's pen category uses the HSV color model. H stands for hue, S stands for saturation, and V stands for value, which we translated to brightness because that's what it is. And to form a color, you need to combine those three values. So shown here in the color picker, the hue is set from 0 to 100 on that color line. The saturation is that direction. So if you have a saturation of 0, it means that you don't have any color, any of the hue in your actual color. So that's basically the color intensity. The brightness is in that direction. If you have a brightness of 0, you don't have any light in your color, so it's black. Okay, so now we need to grab the set block with those three components. So we want to set the pen hue, we want to set the pen saturation, and we want to set the pen brightness. And the value we want to set it to is the hue, saturation, and brightness we measure at the position of our sprite. To do that, you can go to the sensing category and grab the hue at mouse pointer block. The hue at mouse pointer is where my mouse currently is at, so that's the block I'm looking at. But you can also select myself here, and myself in this case is the sprite that you're currently programming in. So the hue at myself, let's try it here with the red flowers in my back. The hue at myself should now be something close to 0 or close to 100 because that's what red is. In this case, we have 1.8. Yellow orange should be a little bit more, maybe 10-ish something, 6.2. That's green, but I'm not sure if it can measure that. It looks more grayish. 26, that's about right. So this just measures the value at the tip of the sprite. And now we want to set the pen hue to the hue at ourselves and the pen saturation to the saturation at ourselves or at the sprite, and the pen brightness to the brightness at myself. If you want to use the same block over and over again, you can just right click and select duplicate. And if I click that script now, you should see that my sprite gets that greenish color that the leaves here have. Oh, wow, it's rather at the gray. Let's try it with my hair. Now it should get brown. Let's try it with the red flower. Now it should become red. Okay, so we can now set our sprite to the color that we measured here. At that point, we want to draw a dot at that position. To draw a dot, you need to put the pen down and you need to put the pen up again. But in between, you want to move something because we have the convention that if you just move the pen down, nothing happens. But if you just put the pen down, nothing happens. But if you move anything in between, it will draw. To draw a dot, you can just move 0 steps. And now I should have a super small red dot here. To repeat that, and to move to different positions, we now need to add a go to random position at the beginning. And we also need to add a forever loop around it. So if I let that run for a while now, it should draw dots. We can already make that sprite here invisible. So I could set the ghost effect, set the ghost effect to 100 to make it transparent. And you can see that I get all those really small dots. But when I redraw the image like that, with dots in size 1, I will just get the original image back, which is not what I want. So we can increase the pen size and set it to 5, for example. And now we get a lot of small dots, and I can make that faster. And now you can see that I can recreate the image with just those dots. Why is this project expandable? Because you can now experiment with different things. So for example, you can just change the pen hue and set it to a specific value. You can not move 0 steps and draw dots, but do lines instead. Let's reset the pen size to 1. Or you can create an effect where you look like you're behind a frozen glass when you point into a random direction, before you draw the line, like this, for example. Or you could not just move lines, but other shapes. So for example, if you wanted to draw everything in a droplet shape, we could tell the sprite not to move 10 steps directly, but to set the pen size to 1, repeat 10 times, change the pen size by 1, and move 1 step. If I clear that and draw, oh wait, pen down, and move it like that, you can see that this is a droplet shaped structure. So for example, I could now wet pen up afterwards and down before. I could now draw everything in these droplets, and I can make them smaller that I can see my face better again. Or I could write my name, I could write the image in my name. So for example, I could write everything just with Jadga's. So now I've written myself in my name. If I make that a little smaller, I can see it better. So this is a project that allows for a lot of variety. We could also, for example, combine it with the random color walk that we've done before to create another experience where we just randomly move around the stage and set the pen size according to the brightness we measure, and so on and so forth. So this is a project that's really great to expand with other ideas. The next thing that I wanted to mention is have backup ideas for faster students. So there are usually some students or participants in workshops that have everything done way faster than everyone else. And usually a good idea is to animate things. So one project that we do a lot is, let me create a new one, is drawing spirals with the for loop. So this is something that we also do as an introduction to variables. So the for loop has that internal variable that automatically increases itself by 1. And we can use that to draw spirals. So for example, I can always move I steps. Let's increase that to 50. So for the first time, I move 1 step, then I turn, let's say, 60 degrees. The next time I go through it, I is 2. So the next time I move 2 steps and turn 30 degrees, then I move 3 steps, and so on and so forth until I reach that 50 here. So if I put the pen down now, I can draw a spiral from that. And some kids can take forever doing that. So there are also interesting shapes. For example, the 121 I like a lot, or the 137 that looks more like a star, or the 179 that looks absolutely not what you think it would. So there are different spirals that look really interesting, but at some point you just tried everything out and you added color and whatever. So here, this is a cool project to just animate it. So you basically want to add another variable that walks through all the angles, and then you draw a spiral, delete it, change the angle, draw the next one. And by that, you create an animation. So let's do that together real quick. That's our spiral. We need another variable for the angle here. So I'll make one. I'll call it angle. And we set this angle to 0 at the beginning. The cool thing is if you're above 360, 361 is the same spiral as 1. So there's no problem just increasing the variable forever. So we can wrap a forever. Okay, we set the angle to 0 at the beginning and we turn the angle. So if I draw that, I'll just get a line, because if I turn 0 degrees, I don't get any like angle. Afterwards, we want to go back to the, or before, we want to go back to the center and we want to face in direction 90. So let's go back to the center before we draw a spiral, and let's face in direction 90. If we do that now again, we get the same line over and over again, but we want to clear it afterwards. So let's clear it. Bam, clear. Okay, again. Okay, this seems to work. Now we can change the angle. I'll set it to 0 here. Oh no, I don't do that. And then we'll change the angle here by 1. So if we do that now, we get 1 degree. If it's done, we get the next. If it's done, we get the next. If it's done, we get the next. And now we can wrap a forever loop around that and see how this looks. Okay, so this is our first spiral, this is our second spiral, this is our third spiral. So that's kind of what we wanted, but we want an actual animation. So what we need to do is we need to draw that spiral right away at the same time. So there's the warp block you can use for that. Let me show that real quick again. So let's go to the center and let's clear. If I draw the spiral like this, it draws step by step, and then at some point it's done. If I wrap the warp block around it and execute the same script, the spiral is there at once because it just draws everything in one single step. So let's do that, and let's change the angle now. And if we now execute that script, we can see that we can travel through all the possible spirals. We can even make that a little slower here while it's running, so even slower. So that's always a good idea to have people animate things, and it also works with recursive fractals. That also works with other drawings that you have. So adding animations is always a good idea as backups for faster students. Then I wanted to mention that it's good idea to create reusable code, and we're running out of time a little bit, so let me just create one thing real quick. So it's often a good idea, especially when you do gaming workshops, to create stuff that you can reuse in other projects, especially complete sprites that you can export and reuse. So for example, what I do a lot is just create sprites that do animations for background. So for example, if you want to do an underwater game, you can have bubbly clones that just move upwards, and you can export that sprite and include it in another project, so you don't have to do the background over and over again. Another thing that works similarly is blocks. So for example, what you need in a lot of games is a jump block. So in this case, for example, we want to make a block which is called jump. And what's supposed to happen when we jump is our sprite is supposed to repeat 10 times, moving upwards by changing y by, let's do 10, that's all right. And then it's supposed to move down again by changing y 10 times by -10. And if we click apply now, and we can always jump whenever space is pressed, we can see that our sprite can jump now. Jump, by the way, is also a block that is awesome for having different levels, because I could also do it by just moving, by just changing y by 100, waiting a little bit, and then changing y by -100 again. Or I could even, so that would also be a jump, it would be worse animated, but it still a jump. Or you could even use the for loop to create an accelerated and decelerated jump. So for example, for I from 1 to, no, let's do 15 to 1, we want to change y by I, and then we want to duplicate the same thing, and for I from 1 to 15, we want to change y by -I. So 0 minus I. Now we start with a really hard or really fast sprite. So the first time it moves 15, then it moves 14, then it moves 13. So we get a deceleration when we move upwards, and we get an acceleration when we move downwards. So this is what this would look like. So that's also an awesome idea if you want to have different levels for differently, yeah, good programmers. So I like the accelerated version best, but this one is probably also super good to understand. As I mentioned, this is about reusing code. So you can always click on the on the file menu, and you can export blocks. So here you get all the custom blocks that you have. And now I can just export my jump block. And this will be downloaded to the downloads folder of my browser. So here I have the untitled blocks now. And if I go to another project, let's say this one, I can just move them in here. And now I have the jump block available here in this project as well. So especially if you want to have gaming workshops and you don't have that much time, you can also prepare things like that so people don't have to do them all the time, or you can urge them to export it and use it for their next project again, because usually in those beginners workshops, you don't get too far. So if you have reusable code that people can then use in other projects, that's pretty cool for them as well. And the last thing that I wanted to mention is don't be afraid if you run a workshop. In my personal opinion, kids are most of the time super easy if you say you don't know things. That's totally fine for them. Also, we are always there in the Snap forum, and that's, by the way, also true for the Scratch forum. If you have a question and you need help, there's usually someone there all the time. Also, there's a lot of resources available. So for Snap, for example, we have courses on OpenSAP with video lectures for a lot of things that you can check back with, or that you can use as as instructions for your workshops even. And we also have some help videos, and I actually promised Philip I would make new ones until today, but I forgot. So there will be new Snap help videos if you for like the things that happen most frequently in workshops, and that you don't feel overwhelmed if something happens and you don't know what to do right away. So that's what I wanted to mention for your workshop ideas. If you want to know anything more, have questions, want to schedule a follow-up meeting, need more resources or whatever, feel free to ask now. Okay, so there's one question: what is the best age to start with Snap? So that depends, I'd say, on the projects that you want to do. We usually say 12. So below age, I can say some words to libraries, yes. So below age 12, it's usually, I mean, there are, of course, things that you can do before, but there are several things that I personally feel are helpful to know. And I mean, the lowest bar, of course, is reading, because you need to read what's on the blocks. So if you can't read, you're probably too young. And there are some concepts, especially things that I love about the angles and so on. I found out in workshops that it's pretty hard for me to explain how angles work or how a coordinate system works. And you can do it, but I would try to avoid having exercises that need knowledge about angles or about coordinate systems or about, I don't know, trigonometry, when you know that you have kids who can't do it. So I think 12 in general is a good age, because then people can grasp most concepts. So Dan Garcia, who's also the main professor behind the Beauty and Joy of Computing curriculum, is currently developing one for middle school in the US, and that starts from 7th grade, I think. So 12-year-olds as well, and he even does higher order functions and media computation with them. US kids have a little more computer science than German kids or European kids in general, but from the concepts, it shouldn't be a problem starting age 12. Okay, the libraries. Snap has several libraries that you can find in the file menu if you go to libraries. So there are some computational ones that Brian Harvey insists on having. So he's the professor from UC Berkeley that we make Snap together with. So this one, for example, just adds blocks to the control category. This adds blocks to the list category. But there are also some that extend Snap for additional features that we don't want to show all the time. So world map, for example, adds, well, let me just import that, adds a lot of blocks to the variables category. For example, the show current location block. Okay, I don't want to allow that block. Okay, let's try that. Set this one. So if I click here, I can show a map here. Does that work?
Just don't want to interrupt, Jadga, but
Yeah.
you stopped share. You stopped your screen.
Sorry, I stopped sharing my screen. You're
Yep.
right. Okay, let's try it again. So I imported the world map feature, and then I didn't allow it to show my current location, so now it's broken, unfortunately. So maybe let's set the zoom to something smaller and see if it works. Okay, so I broke it because I didn't allow it. Let's import another library. So for example, we have the text-to-speech library. This one's kind of interesting because I didn't share my computer sound, but I think you should still be able to hear it because I'm just using my desktop audio. So wait.
Hello, world.
Did you hear that?
Hello, world.
Yes, it works.
Okay, so this, for example, lets me create text and lets me speak text through my speakers. This is, for example, a cool extension. If we have one exercise where we generate random sentences that works great in English by just randomly selecting a predicate and two nouns. So for example, Jadga likes ice cream or whatever. And then you can use that as an input to that text-to-speech block. And that's, for example, a fun activity. And there are several libraries that extend Snap by fun things. You can also make your own libraries, as I just showed you, by exporting blocks. So a lot of teachers that use Snap create their own blocks libraries for, I don't know, their physics lessons, where they have all the constants that they need saved as a block. For example, they make a pi block and they make a Avogadro constant block, and then they have different functions that let them calculate different things, and then they just share that among the students. So you can also make your own libraries. Okay, any more questions? Can you see my screen now? Okay, great. Okay, any suggestions for beginner workshops with not so much time and a specific topic? Yeah, there is a possibility to have less blocks. You can hide them. So there's a, I can just hide blocks that I don't need. There is a way to do that with the list, but if you really want to do it, it would be great if you could approach me afterwards, because that's too time intensive to show now, but you can definitely hide blocks. And if you want to show them again, you can just use show primitives. It's easier if you only have custom blocks, because you can hide all primitives and then you can see only the custom blocks that you've made. So that's something you might want to do. And then there was another question. If you have different levels in one class, how do you give instructions? Yeah, that depends. So sometimes I put the additional things on extra. So if I write down things, I usually try to have the take it further activities on a different page, so you don't feel bad that if you don't do it. But if you walk around and you see that someone has already done things, you can just hand them out. Also, it's a good idea to name them something like take it further, so that kids don't feel like it's something that they require to do, but rather that the others are faster and not that they are slower. So that's usually how I do it. Okay. Any more questions? Okay.
All right, Jacek, I'm not sure if it's just me, but I can't hear you anymore. Now. Well, then I take over for the moment. Jadga, thank you so much for taking part, for enlightening us about Snap. It was a real joy and pleasure to listen to you. I know that there will be some more. So for all of our esteemed participants and attendees today, there will be more from Jadga. So please stay tuned, follow us on social media. And last but not least, thanks to all of you, to our Meet and Code NPO community, thank you so much. Stay tuned. And also keep in mind that the registration will open rather sooner than later on the 1st of June. So stay tuned, have a nice one, and talk to you soon. Bye-bye.